In this example, we want to find the Laplace transform of this piecewise function. You can see here in the diagram there are two blue lines. One started from 0 to 1, it is lying on the x-axis, or you can say on the t-axis, and the other line is over here in the first quadrant starting from 1 1, and this is a point 2 2 and goes on. So what we will do, actually we have to represent this function in terms of a piecewise function. So there are two lines. The line 1 is starting from 0 0 to 1 0. This point is 0 0 and this point is 1 0. If we want to make an equation of line, so we have to find the gradient. So m is equal to y2 minus y1 over x2 minus x1. So what we have right now, this is 0 minus 0 and over 1 minus 0. So actually we have the gradient is 0. So we can use any of the point for equation of a line. So this is an equation of a line, m into x minus x1. Here you can see y minus 0, you can use any of the points. So I am using the first point. Y minus 0 is equal to 0 into x minus 0. So this is equal to y is equal to 0. Here y is actually f of t. So f of t is 0. Actually most of the students may be surprised to see this particular solution, because they all know that the straight line parallel to x-axis, or x, the equation of x-axis is always y is equal to 0. So we can write this equation directly from the function, but I have to solve it just for the sake of just for the students to understand the concept why we are taking y is equal to 0. Similarly, we will use another equation. So the other function, what we will do, we have 2 points, 1 1. This point is just a 1 1 point. So we will say 1 1, and the second point is 2 2. If we take these 2 points and we want to find the equation of straight line, so first we will find the gradient according to the same formula, y2 minus y1 over x2 minus x1. So gradient will be 1. So we can use any of the point. I'm using this point 1 1. So y minus 1 m into x minus 1. So particularly what we have now, minus 1 will be cancelled, so it will be x. So f of y is basically f of t and x is basically t. So now we have construct the equation of these two blue lines, and now we will represent this function as a piecewise function, and that piecewise function is f of t. The value is 0 from 0 to 1, and the value is t if t is greater than equal to 1. Now this is our piecewise function which we have extracted from this diagram, and now we will find the Laplace transform of this particular function. So according to the definition, Laplace transform of this particular function will be, so we will write from 0 to infinity e raised to the power minus st f of t. Actually this is our definition of the Laplace transform. Now we will split our integral from 0 to 1 e raised to the power minus st. From 0 to 1 we will pick this function, that is 0, and then from 1 to infinity, because t is greater than equal to 1, it means there is no bound for t, so it goes up to infinity. So e raised to the power minus st, and dot, in this particular case the function is t. So we will select this function, and this is our integrals. Now we have to solve these integrals one by one. Here this is 0, so this overall integral will be 0, and what we have left, we have just left this integral 1 to infinity e raised to the power minus s t dot t. Sometimes it is difficult to evaluate integrals. We can convert this integral in terms of a limit if we take b approaches to infinity and we say that 1 to b e raised to the power minus st dot t dt. Now we will evaluate this integral and limit b approaches to infinity, and we will solve this integral by using the definition of by parts, by the method of by parts. So how we can solve this? The first function as it is, integration of the second function, that will be e raised to the power minus st and divided by minus s. This is 1, this is b, and then minus 1 to b and e raised to the power minus st over minus s dot the differentiation of the first function, that is t, that will be 1, and this is our. Now what we will do, actually this is limit b approaches to infinity. Actually, what is the purpose of taking a limit over here? Because sometimes we need to solve the this type of expression. If we apply b dot e raised to the power minus bs minus, and then we apply 1 e raised to the power minus s divided by minus s, and this bracket will be closed and this minus will be plus, and what we have 1b and 1 over s is also out of the integral, and we have e raised to the power minus st dt. This limit is also for this particular integral, or if you want to remove the limit from this particular integral, then you can replace this b as infinity. In this way there is no need to use limiting value of this sign particularly. Now I can write again limit b approaches to infinity, and we have b dot e raised to the power minus bs minus e raised to the power minus s divided by minus s, and we have removed the limit sign from here, so it will become from 1 to infinity e raised to the power minus st. What we have done here, just copy and paste the previous step over here. Now we will continue this expression. So just check, if we take minus 1 over s is out of the limit, minus 1 over s is out of the limit, and limit will be applied only on this particular function. Here you can see b over e raised to the power bs, and this is actually a constant, so we will not apply limit over here, or you can say if we apply, nothing will happen because there is no b involved in this expression, and this minus or this minus will become plus, and you can say this is this type of function, and then 1 over s, and if we integrate this particular integral, so it will become e raised to the power minus st divided by minus s, and from 1 to infinity. Now what we will do next, now this is obviously all the students know the Lopital rule in calculus. Whenever you have a limit and whenever you have an indeterminate forms and limits, because if we apply infinity particularly instead of b, so this will become an infinity over infinity form, and these type of forms are called indeterminate forms. And whenever you have an indeterminate forms, you always use a Lopital rule, and I'm sure everyone knows about the Lopital rule. And what is Lopital rule? You have to differentiate the upper function with respect to b, and similarly you have to differentiate the lower function with respect to b. If we differentiate the upper function with respect to b, then it will becomes 1, and if we differentiate the lower function with respect to b, it becomes e raised to the power bs dot s. Now this is the limit is still there, because now you can apply limit over here, but before that you have to establish the other part of the, so this minus and this plus will be minus 1 over s square, and then we will apply the upper and lower limit. So this will become e raised to the power minus infinity, and this will become e raised to the power minus s. So this is our final procedure. What we will do next, so this is 1 over s, and now you can use the limit over here. If we use the limit over here, so it will become limit b approaches to infinity e raised to the power minus bs dot, you can say this s will be out of the limit, so you just have this expression and then e raised to the power minus s over s minus and minus plus, and you this will be 0, and you must have right now e raised to the power minus s over s square. This expression will be 0 because when you apply infinity instead of b, obviously e raised to the power negative infinity will be 0, so the whole expression will be 0. So ultimately at the end, what we have left, e raised to the power s over s plus e raised to the power minus s over s square, and finally the Laplace transform of this piecewise function will be e raised to the power minus s over s plus e raised to the power minus s over s square. So this is our final answer for this particular piecewise function.